A song
Oh, I found it.
called Going to Bethlehem. Going to Bethlehem. Well, you can't slow down. Follow the stick. Stop.
I did see.
Ready?
Gonna take
So quick review. We are not going to do any type of building metallic structures like we did with fluid structures for covalent and the giving and taking process of ionic. It's very difficult to show the communal sharing of electrons within a metallic bond, as you can imagine. Okay? But let's remember, okay, metallic bonds are between what things?
Metals.
Metals, okay? And typically metals have high, low, or medium electronegativity values. Low, okay? Well, what does, I mean, great, they have a low electronegativity values. What does that tell you about them, though?
You're gonna give a
Okay, because they have a very low desire to pull electrons to themselves. And so really, it's the opposite way that holds metallic bonds together. Everyone wants to completely give, and because of that, what you have is a whole bunch of free-flowing electrons, which they call electron C theory, because the reason why I call it the electron C theory is because it's the electrons are very fluid. What do I mean by that?
They're not like.
Yeah, they're not rigidly held in between two nucleuses, kind of like covalently bonded things are, and they're not, you know, like ionic, completely given from one side to the other, and they're just kind of stuck by the guy that's more negative. These guys are really fluid. They flow all over the place, like a hot potato being passed around, right? Okay, but because there's so many electrons that are being passed all over the place, right? Imagine you guys are your positively charged nucleuses within a metallically bonded structure, and I'm, you know, say Trinity's electron. Okay, and she's passing me all over the place, okay? And then along comes, you know, maybe Morgan's electron following behind me, and then there's Gage's electron that's wandering around here too. Okay, at any given time, there should be approximately an electron in between the nucleuses. You're not paying attention.
It's like, yeah, in between the nucleuses.
What did I say before that?
The proton. Like acid. That's biology, dude.
Electron.
I wasn't really listening, but I know what you said.
Why are there? Oh, electrons in between two different nucleuses. See, I know this.
How does that work?
I got you. It's snack hour. Sorry.
I'm sorry.
So like, I heard you. I
Right,
heard you talking about it.
cheese cake.
I heard that like, and then I was looking at my crackers. I was trying to open it. No, but I listen.
Can I have a paper towel?
I'm so glad what I say is about as valuable as staring at a cracker.
I have a
Well, it's just like our brains cannot multitask.
I understand.
That is a proven fact. So it's like that is. I'm trying to open these crackers.
It's pretty true. Like,
It's true.
like
Our brain cannot multitask.
my wife.
Effectively, but it can.
No.
Look at this
it
ham
cannot.
and cheese. I mean,
Like,
no,
a woman
chicken.
can eat this head
Sit
dry.
down and stop.
Shit. You're not gonna go heat that up.
I'm not. It's heated. It was just telling me to look at it.
Okay. It's kind of funny because like at night, my wife and I have conversations and we talk and sometimes she's like, hey, you know, can you do the dishes? And so I'll be doing the dishes. She'll be trying to talk to me. I'm like, dear, I can't do the dishes and talk to you. Like I can't. I literally can't. Like, if you want me to listen to you, I gotta literally sit down and focus on you because if I'm doing the dishes, I'm focused on the dishes. I cannot hear what you're saying. Like literally, I can't.
Women multitask a lot better than men.
I
tried to do it. My mom says do this while doing this while doing this. I'm like,
I'm putting groceries in the back.
okay. And then she's like, hey, you take the pizza out of the oven? I'm like, no.
I don't know. Maybe you got
No,
more
like
female genes in you than can. I don't know, man.
Like,
I literally can't
brush
do
my
it.
teeth. I try to do something else. Then when I try to do something else, I just sit there with the toothbrush, not moving.
Exactly.
It's
Yeah.
like you can't.
I do so many different things.
But you're a woman. Give us men a break.
They actually say that there's no such thing as multitasking completely. Like you cannot do two things 100%. Like what you end up doing is, so with guys, it's either 100% one and 0% the other, or 100% the other and 0% the latter. And with girls, it's like maybe 60-40 or like 50-50 But you can never do two
You
things.
can't load the dishes and talk to someone.
I cannot.
It's not even hard.
I'm like loading the dishes while watching TV while listening to Miles' choir music while talking to someone.
Which that's like 20% each. You know, you're not really getting.
Yeah, but you don't have to be doing, well, I don't have to be loading the dishes.
Talking about the phone and walking are two
Absorb it
different.
fully,
Yeah, but walking's subconscious.
No, but like doing the dishes, like you
I
can
like
clean
going
them
to the store, and then
100%, but not be
I was going
paying
to the
attention
store,
to it like
and I was
100%. So like you're still
Okay,
getting
what was I
everything
getting?
done.
Your brain control.
Okay, but
If
you
you're
probably
like,
don't know this, but hypothetically, would you be able to drive to
Once
a
you- once you-
podcast?
You could do it. Would you get?
No, but would you be able to?
I would not be able to get much out of the podcast. I can maybe get some, but yeah, I would not be able to get it. Because I focus, what I'm doing, I'm focused on. Maybe that's more than me, gauge only.
I feel like that's a lot of guys.
Alright, so let's go back to here. Metallic bond, what really is going on is they're not really giving and taking, because no one's really taking. They're not really sharing per se, because none of them want. And so really, it's really sharing by not desiring them. Okay? And so what ends up happening is these electrons that are moving around have to be moving around. They can't be completely lost, because if that was the case, what would these two nucleuses do to each other?
If there wasn't what?
Probably. What would they do if there was no electrons in here?
They would just do nothing.
Well, they would repel, right?
You know, split
Okay.
apart, and the metal won't be a metal anymore. And
Right? And this is why metals tend to be very malleable, is because you can kind of bend and move things, and the nucleuses can move a little bit because there's electrons kind of in between them, keeping them from actually severing. Okay? It's interesting. So these electrons that they don't want still kind of act as the glue that holds them together and
Are you
keeps
gonna
them
pull
from
up the metal?
separating. How many times have you guys played with that metal though? It's breaking apart because everyone keeps malleabling it in the same spot.
Well, it's hard to start a new spot. You like
I know.
the metal that they pass around.
like the lead.
Oh.
Okay, this shouldn't be too difficult.
Just have just key words that guys don't have to say a full sentence for them to understand it. You just say
Girls can do
you
that.
can just say tiny little words and then you'll
yeah,
understand them.
Yeah.
Girls do that.
Yeah, they say,
guys.
like, my mom and sister
One
had to
word.
explain
I feel like
everything.
All right, hey, back.
I feel like girls do that for both guys and
Hey,
guys.
hey, everybody! We're not doing anything productive today.
Oh,
Goodness.
The government. Sorry.
So, predict the predominant type of bond formed here. This should be fairly simple.
Covalent.
But you should probably say not nonpolar. What and do?
Polar covalent.
Okay, and I would say these guys are relatively close in electronegativity values, and I wouldn't even say this is very polar. It's just slightly polar.
Because they're one.
It's only non-polar when it's the same element, right?
Yeah.
The bond is only nonpolar if it's the same element, but you
Wait.
can have a nonpolar molecule with all polar
Like-
bonds.
Like
Yeah,
you had
like,
oxygen
like-
and sulfur.
So carbon, chlorine 4.
Yeah, or like something like this. Technically, guys, all of these bonds are polar bonds, but they're polar bonds in opposite directions.
So they
because-
balance.
Yeah. Okay.
Metallic.
Okay, what's the next guy?
Ionic.
Metallic.
You could have
And could you then describe what's going on with all of these electrons in each of these situations? What's going on here? Sharing, but be more specific.
Sharing towards oxygen.
Okay, or unequal sharing towards oxygen. Okay. What's going on here with the electrons?
Potato.
That's not going on. It's the communal sharing. And what's going on here?
Give and take.
Give and take. Now, is it actually giving and taking?
No.
It's just very, yes, extremely polar.
Polarity
Okay.
towards the floor.
All right, let's just have you guys do some of these for fun.
Did you see my sister's
Fun.
What?
Okay, I want you guys to do these. I want to just check. I want to do this really quickly, just so that we're good with this. I think you guys are doing fairly well. Ooh, excuse me.
Oh, we're almost done with the chapter, aren't we?
We are almost done with the chapter. You will probably have a quiz Monday.
How many of us?
Everybody hear me? You will probably have a quiz Monday.
Come on. It's a good thing you repeated that.
Actually, you will have a quiz Monday, regardless of whether or not we have workathon. Well, unless we have workathon on Monday.
On Monday.
The only thing that would stop you from a quiz on Monday would be a workathon on Monday. Everybody hear me?
That would be the best, because then I can just.
Wait, why are they thinking?
Sunday night is like another
Because
weekend.
it's supposed to snow.
It's not supposed to snow.
That's
I
Saturday.
don't
Don't have like everything.
feel this second.
Hey guys, really?
I just checked this morning. There's a 20% chance of rain.
Oh,
yesterday.
It's not even getting cold enough to snow.
Okay,
Guess
regardless
what?
of this, it's supposed to be like 25 miles an hour.
Penn State
You
is
wanna
playing
like
Ohio
shovel
State.
snow and
On
break at the
Saturday.
same time? Okay.
Huge game. Huge.
Gosh, fuck.
Okay, can we do this? Kate,
Wait
you
a
done?
second.
Kind of on the board.
There we go. Can I do the other one?
Yeah, why don't we do this? Why don't you guys do it individually on your own, on your sheet, and then you guys can come up and do it on the board.
Okay, I'll do it.
Wait, never
Oh,
call.
my soul.
Oh,
Oh, was it on there?
Yes.
Well,
Everything I give you in your packet is
I
there
forgot.
for a reason.
I don't know how you do
Oh, do you want this?
Oh, can I do it if he doesn't know how to?
I'm not entirely sure, but I'm
You
thinking.
didn't make it symmetrical. That's okay. You did good.
I didn't do that right.
What the heck?
Because this is still.
Oh, I'm doing the wrong one.
That's gonna be negative.
Good job.
Oh, it is?
That's
Well,
the most
they pull it
electronegative
towards
element
it.
on there.
Well, then these are negatives too.
No, well,
Yeah.
no. So what's gonna end up happening is, even though these are pulling electrons this way, this is gonna pull more, and so you're gonna, yeah.
That chlorine is more.
Oxygen is the second most
Do we
electronegative.
have to put those when
It goes, I think it goes fluorine, oxygen, nitrogen, and then chlorine. I think.
It could,
Something like that.
That should be
There we
nice.
go.
I like
Okay.
that color.
Okay. Rolling. Try drag.
I like making this double bond.
It's not an S.
I like.
It looks like
It's a Greek symbol.
It is an S. It's
Whenever I
a
go to the board, I realize how bad my hair is.
Oh,
It's all like.
One track mind right there,
Couple
fellas.
months now.
Alright, you should see. Everyone get that one. Hey,
I had to water it down.
hold on.
So I woke up with my hair.
Hello. Hey, yes.
Honey, your hair is short.
Yep. Yep. Leaking what? Okay.
Ooh, tricky.
I don't think that's right.
Why?
Well, it doesn't really matter.
$92.99. Okay.
Or
Did you check the catalytic converter? Oh,
like this?
alrighty. Yeah, go ahead and replace that. That's fine with me. Alright, thank you.
Yeah, what are you saying?
Yeah.
Remember, which one of these would you do?
Which one is more correct?
Would you do that one or this one?
Whatever you choose.
See?
Okay, there probably is one specific way, but I don't know which it is.
Or,
Okay?
there we go. Beautiful.
My guess is this, just because. Well, I don't know. I really don't know. That's just a guess. Okay, Tanner, did you get that? One of those two?
I got one of them.
Oh,
Yeah, you don't have to put both, guys. Just one's fine. Tyler, did you get that?
Both got they both.
Oh, you did both of them? Okay, all right.
Were we supposed to put the partial symbols?
I mean, I would get in the habit of it. Technically, I'm not gonna. I don't know if I actually fully cover that. What's 6C about?
Describe the general properties of compounds according to predominant bond.
Okay, yeah, I don't think I actually do this until later, but it's good to get in the good habit of trying to do it now.
Okay.
Okay? What you're looking for is the most electronegative element is going to pull electrons towards it. And so that's typically, wherever the most electronegative element is where the negative side of the molecule will be.
Okay.
Okay? Unless they're on opposite sides, like you had your two most electronegative are on opposite sides, like this. So yeah, these are still your negative sides, but those are opposite charges, are they? On the opposite region. So this would technically be a nonpolar, and this would be a polar. And actually, there's an easy way to do this. It's called the symmetrical test. I'll show this to you later, but I'll just do it now. If you can cut it in half, vertical and horizontal, and it gives you mirror images both ways, it's nonpolar. If it doesn't, it's polar. So which one will that be?
That'll be.
It's polar, right? If I cut this in half, is it a mirror image on both sides?
No, just one
No,
side.
neither way. But if I cut this in half, this way, or this way, do I have mirror images both directions? That's going to be nonpolar. Okay? That's just a quick way to do it without having to think too hard about it. Okay? Alright, got a couple more
another
difficult
question.
ones. I think we've already done this one before.
Yeah.
Do we have to write both
Do one of them that
Lewis structures?
Yeah, I don't know, on the homework, I was so confused on like the last two.
Yeah, I don't know if I can come with just a brand new one on top of my head, but we could probably review one.
That would,
Why don't we do these, or are you guys already through all this already? Are you guys just,
Do we have to write both Lewis structures if there's like?
no. Okay, why don't you guys do this?
nice.
I mean, the one after this one is kind of a goofier one, I think. So that would be a good one to go over. The one after this bottom one here. Anyone new want to come up and do the HCN?
Oh. Well, damn.
Do I need to do the partial thing?
It's pretty easy on this one.
You're doing the wrong one.
Wait, which one did you?
No, you're doing that one.
Oh, just kidding. I thought you were doing the other one. Not bad. Yep.
Now, we've done this one before. We've done this one before. Do you see in this, the trend here? There's only so many of these guys I can give you. You know, I could show you carbon with phosphorus, but it's going to look exactly the same way. Carbon, phosphorus, and hydrogen as carbonation and hydrogen because of their location and number of valence electrons they have. Anybody else different want to come up and tackle this one? I know we did do this in your homework, so it probably isn't as difficult as now as it once was. Anybody? Give it a try.
I want to see if I got this one right, because this was one of them that
Oh,
I made an attempt, we'll see how.
that's okay. You know, that's how you learn if you mess up.
Amen. Amen.
As long as you get help with what you messed up on.
See, carbon only has 6 right now.
Okay, so where did this, you're close, but there, here you would have that unbonded electron there.
You added.
Hold on.
Oh, yeah, yeah.
You don't take away, yep, this means add. And so if you look at it, I've got,
Never mind.
Yep.
So close.
no, very good, good job. Okay, so if you add, assuming you just want to remember that negative means add, you would have been just fine.
Only chemistry. Negative means that.
Yeah, it's gonna mess
Well,
up.
That's not
that's
true.
math too. When you
If you add a negative number, it's still
Okay, no,
negative.
stop.
And math is the same way.
Wait, okay, so
That's
what
gonna
does
mess
this show how
Yeah.
calcium and iodine?
Just like you take advanced chemistry and physics where like negatives tell you direction. And
How about
positives tell you
no?
direction.
Are you
How
gonna?
about we die?
Like if you compress a gas, that means positive. If you expand a gas, it means negative. Work.
Well, that would make sense because no, it wouldn't actually. Oh, yeah, because you're
Depends
adding
on-
electrons to make. No, I'm not leaving this.
Okay,
You got addition.
are you just gonna have one of each or?
You can add.
You just have.
Nice.
Okay, moving on. Anyone have questions? I don't want to assume that we've all got this, you know, peachy.
I think. Okay.
Did I turn this on? I hope I did.
I saw you back there.
You were back there.
Yeah, I did. Okay.
You did? Yeah. Can we do the next one?
Yes.
I thought this was like one of them on the whole because.
Okay, this is one of your goofy ones. It's goofy in a couple things. First off, the first goofy thing here is the central atom is not what you would expect. Okay, it's not oxygen.
Oh, yeah.
Can it be?
Oh, I did.
It won't be.
Cl2. Nice.
You could probably do it in a way that makes it look stable.
Is that
It
a
just isn't going to do that.
CL or a C?
But how do you know
It's
which way is right?
Practice.
I thought it was carbon and iodine.
Yeah,
I'm like, how
experience,
does this work?
really, in all honesty. So yeah, this is not, common mistake, this is not carbon, iodine, and oxygen.
Okay, good.
It's chlorine with oxygen. So typically, there are two things you need to look at for central atom. Most of the time, it's the most unpaired electrons will tell you the central atom. Sometimes, if you've got a guy that has multiple, typically, those are going to be your surrounding guys. The one that's by itself, or only one of them, or the least of them, will be your central atom. I know it can be difficult, and the only way you would know is really just experience. There's not a real clear-cut explanation for these. Okay, now I'm going to make sure I put one of the oxygens toward the unbonded, but there's nothing I can do about the other one. Okay? Form the single bond. I'm going to take one of these and form a single bond.
Oh, you can do that?
Yep. Yeah, I didn't, yep. There's a lot of, oh, you can do that. It's from yesterday.
Okay, that's.
Okay? You can also do this.
That solves
Give that
everything.
You can also do this.
Do that.
What the
And
heck?
then add the one you
Okay,
just
we're going to
added.
do that. And the reason why we can do this, guys, is because oxygen is more electronegative. And remember, in the end, it will do whatever it needs to become stable. All rules are out the window as long as it's stable.
And then you add that one to.
Okay, and then the one that you add due to this negative charge would go here to make that guy stable.
This makes so much sense now.
Yeah, you should have come in yesterday after school with PHM.
I didn't know you guys were coming after school with me.
We said it. Yeah, you didn't know he was coming. Oh.
Were you coming to get help, or are you just coming?
I was just making sure we didn't have to work.
So you weren't really coming.
Well, we were diligent.
I was just gonna bring my chemistry book, and what would have happened is I would have looked at my notes and done today's homework.
Yeah,
Last night.
Alright.
And now when it came this morning, it said,
Okay.
oh man, I didn't have to do that. And I was like,
Alright, now this is showing how they bond ionically, which is different when it comes to their electrons. Again, what do they do with their electrons on these?
give and take.
Give and take, okay? So we're not doing Lewis structures for these guys. We're doing the second method that we talked about.
Formula unit thing?
Okay, doing our formula unit. So calcium has your 2 valence electrons, plus your iodine, which has how many?
7.
Okay, and remember, we need to be stable. Stable with an octet. Okay? Well, Mr. Kramer, how does calcium become stable if it's giving its electrons away? How does that work? Did I show you guys the other
Yeah,
day
you need 2 islands.
the rings, and I showed you how when you lose it, the lower energy level has a full 8?
Yeah,
You guys
you
remember
should.
that? Okay. So, let's take one, make iodine stable. Well, calcium's not stable, so I would need
Another eye. Whatever.
okay, you must have the arrows. I want you to be able to show me where they're going. They're not just, wanderers. Okay? And keep the negatives away from the negatives and the positives as far away from the positive things. What's the charge of calcium?
+2.
Why is it 2 plus?
Because it lost two.
It's important. You have to, if you lose more than one, you're going to have more than just one positive charge. If you gain more than one, you're going to have more than just one minus charge. I'm going to keep the iodines away from each other. I do want a full dot notation structure for iodine, and it's just one minus. Why only one minus? I need to show that I still have my 2 iodines though. So what is the formula unit for this guy?
CaI2.
Okay, I got 2 iodines, 1 calcium. CaI2 would be your formula unit. Do the next one. If you haven't already. That one's a little bit more difficult.
Can you tell me if I did it right?
Trying to be able to memorize how many electrons they have.
Well,
Whoops, I forgot to write.
yeah. It's a little arrow in the
Arrow between us.
like
Oh,
showing like
showing
this is what it was, this is what it is now.
Wait, do you just put on like bottom or top?
Yeah, just gotta give them. Now do the best that you can. First of all, let's charge the gallium.
3 plus.
3 plus, because it lost 3. Do the best that you can to keep the bromines as far away from each other as possible. Yeah, linear is usually not the best way when you have 3 of 1. Like that. Now, if I could arrange this 3-dimensionally, what you would have is those 3 around the gallium, right? And then you'd have another gallium, and it would be a goofy structure, but you'd be able to maximize your positively charged repulsions, maximize your attractions and minimize your repulsions as best as you could. All right? That's it, isn't it? Or is there something else? That's it. I don't think you guys are good enough at this yet, so. There's the backside.
Oh, Sydney was sad that I missed that song. Oh, in the locker room. She's like, Trinity, you missed the whole thing.
Why didn't I see how it is? Yeah, see how you set it up? How they're all.
No, there's ooh, peanut butter.
That's actually peanut bromine.
It's actually phosphorus.
Wow. That depends on your definition.
It's not.
I don't know either. Illuminati is real. Whoa, Natalie, where'd you do this so fast? What? Actually, you did it wrong. Just be as far away as they can. Thank you.
They are. No, there's 2 on top.
Look at that.
No, but you have to have 2 more on phosphorus.
2 more phosphorus. Yeah, you do.
You can't just shove them in anywhere.
You're right. Well, no, I did. See, I can't.
Well, phosphorus has 5 in it.
You're right, Marty.
Is someone's calculator here?
And 2.
Okay.